All right, folks. Hey, welcome. This is the Smart Buildings Academy TV episode 7. And in this episode, we are going to begin diving through controls engineering. By the end of the next couple weeks, you're going to have a pretty good idea how to take something like this and like this and like this and turn it into something like this and like this and like this. So our goal of today's episode is really to get ourselves really familiar with the controls engineering process, the steps that you're going to be taking. We're going to dive through each one of those. We're going to show some examples of some different deliverables that you are going to be using as you move through the different controls engineering phases. And we're going to talk through some kind of tidbits of knowledge. All right. As always, my name is Phil Zito. I'm the founder and CEO of Smart Buildings Academy, where we provide online training and courses to building automation professionals to help them get the most out of their career, as well as to companies to help them really develop their team and their employees. So what is the controls engineering process? Well, if we look at some notes from today's episode or today's podcast episode that released earlier, you can see that the controls engineering process is really broken out into 5 steps. And that's the release to operations project review, the project takeoffs, so performing takeoffs, addressing physical points in I/O, sizing the controllers, and then handling the architecture. So whenever a project is booked, typically what will happen is a salesperson will produce something like this. It's a scope of work. If you've never seen one, they are typically structured in that the base proposal includes whatever. There are assumptions for whatever was scoped, and then there's any exclusions. Now, the scope of work is typically developed off of construction documents, mainly the mechanical, electrical, plumbing plans, or MEP plans, and the CSI specifications, CSI master format being what is used primarily here in the United States where I teach. So that being said, when we do a release to operations project review, we are reviewing that scope of work and required documents. I like to follow a very structured approach to my sales to operations handoff and my operations review. I like to look in and make sure that I understand who is on the project team, that I have the latest drawings and addendums, and that I really understand any nuances to the scope of work. When I'm looking at a scope of work, ideally what is happening is that the salesperson is doing something like this. They're talking about the systems that are in scope, and I'll show you where this all comes from in just a second. But they're talking about the systems that are in scope. What they are not doing is saying, okay, we are going to use a VMA 16 model, whatever, and we're going to use this model temperature sensor. That's really bad. When, as much as possible, people who are writing scopes should avoid giving specific product details and specific device details. And you'll understand why as we move later on in the process. We're also going to walk through the mechanical drawings with the salesperson, really understand what is going on. We're going to spend most of our time in the equipment schedule, which is right here, and we'll look at this in greater detail later in this TV episode. All right, so let's go back to our process. So from here, we're going to move into takeoffs. This is where we're really going to start to build out our scope list. Ultimately, we want to end up with something like this, where we have detailed out our scope. How many devices do we have? Are there any special notes? Where are they found in the sequence? Where's the MEP found, rather? Or where's the information found in the MEP? Where's the sequence of operations found? And just little nuances and details. So let's take a look at actually doing this. So what I would do during my takeoff, right, because we're following this 5-step process, I would first do my system count. So I'm immediately going to go to my system count right here on my equipment schedule. Note, the equipment schedule is not always necessarily accurate. This can differ depending on the stage in which you're looking at the MEP set. If you're looking at SDs versus CDs, you may get a completely different system count. So it's really important to understand where in the document development lifecycle you are when it comes to construction documents. But for this is a completed set of CDs, and they're 100% CDs, and we're going to go with it. So we see we have 25 VAV boxes. I can see that they're VAV and not CAV. I can see that they have heat. I can see that it's SCR heat, which gives me a different methodology to controlling the heat. It's basically proportional control of electric heat using a silicone rectifier. And so now that I know this, I am going to go into my scope and start to document it. Okay, VAV reheats, and they are on MEP page 402. But now I need the sequence of operations. So I'm going to go once again, and I'm going to scroll through and eventually find the sequence of operations. So I'll find it right here, and I could copy this if I wanted to. I highly recommend when you're doing any hardware engineering that you copy the sequence of operations exactly. You can definitely submit RFIs and RFCs if something is completely out of whack, but you should not take it upon yourself to fix that issue. You're most likely not a licensed engineer, and assuming the liability of changing the sequence of operations should not be something you willingly take on upon yourself. If something is funky, just submit an RFI, request for information, or RFC, request for clarification, in order to get things resolved. So we have our scope matrix. We've started to build that out. We can kind of see it built out here. Now, this scope matrix, if we follow our process, is going to lead us into the specification. Now we're going to start to look at the specification, and we're going to really see, is there any more flavor we can add to our scope matrix? Because the MEP is meant to be the actual design for where parts are going to be, how they're going to be laid out, how they're going to be installed. This is what the mechanic is going to use, the mechanical contractor is going to use to install things. The specification gives kind of, whereas the MEP set is like the skeleton, the specification adds the muscles and the skin to that body that is the project. And it starts with the general section, which gives basically an overview of the control system solution that should be provided. Then it moves into section 2, which is usually called materials. Sometimes it's called parts. Sometimes it's called equipment. So we'll see, what are they calling it on this? They're calling it products. So we see part 2, products, and it goes through the products that are going to be provided here. And it gets into great detail on the IO and the different things that are going to be needed. I'm going to scroll real fast to the IO here and get us down here. We can start to see it gives a lot of details around our IO. And then it also has execution, where it's going to give greater detail on installation methodologies and approaches. And it's also going to talk about the sequence of operations. This is an area where you have to be careful. It's commonly known that there can be spec and MEP set sequence conflicts. When you get a mechanical that drafts the drawings and they do it based on their interpretation of the system, or maybe the sequence of operations from the manufacturer that they base their design on, and then you have kind of the boilerplate sequence of operations that the consulting engineer put together, you will have two completely different sequence of operations. I see this quite commonly, and you have to reconcile that. And it's not, once again, it's not your job to reconcile it, but you do want it reconciled because that will affect the IO ultimately that are on the controllers. So from here, we would have a fully built out scope of work. We would validate that scope of work against our project scope letter. And once that's done, we start moving into the next phase of the control engineering process, which is addressing physical points. This is where we're really going to seek scope alignment. We're going to decide, are we doing any value engineering? Are we doing any alternates? And let me give you an example that I like to use this spec because it has some goofy part selection in it. And so I'll get back up here to zone temperature sensors and you'll immediately see what I mean. If you've been doing this for a while, you'll be like, oh yeah, that is kind of goofy. So this is a school, but yet they're using 4 to 20 milliamp platinum RTD elements. Okay, why? Why would you use that? That's adding significant cost to your project. We're not dealing with long runs, as you'll see in the mechanical plans. If I scroll up to the floor plans, they're very short runs from the actual controller to the actual sensor. Not long runs at all, right? We can see that right here. And there's not a lot of interference. So what's the point behind adding that extra cost? So that would be something that we could potentially do an alternate for. But what we'll start to build out is we will start to build out actually our points list. So we'll start to build out our points list, and our points list will then be used to actually drive the selection of our material. That's how I like to do things. I like to look at the controller, understand all the points I'm going to have, and then once I understand the points I'm going to have, I build out my material for my IO, and then I'll move into my hardware, right? So as you can see right here, I address my physical points and then I size my controllers. So what that does for us, so for example, if I go to right here, system diagram, we can see basic, this isn't complete, but you can see I'm starting to build out my bill of material. You can see it's referencing my point names, and I start to select my parts and pieces for the system. And it's important because now I've selected IO. I have my points name defined, which is going to be very nice because that's going to parallel into my point-to-point checkout and my functional test very easily. And once I've sized this and figured out that, then I can go and pick which kind of controller I'm going to provide. Now, naturally, I will look at what controllers they allow in the product section of the spec. So if I get into space control, I think they use ASCs, application-specific controllers for VAV units and the fan coils. And then for the rooftop, I believe is an AAC, if I remember correctly. Let me take a look here. Yeah, so an AAC, and this will be handling the rooftop. And then we have just some more specific building controllers, and these are going to be our supervisory. So this helps us define our architecture. So we've sized our controllers. We have to think about what are we trying to achieve. And this is why I say handle the architecture last. Because what will happen is we've got our controllers, right? And we've looked at our controllers and we've figured out the IO they need. But now we say, okay, is this a commercial office building and they're really focused on first cost? Well, in that case, maybe we just use edge controllers. So like an IP controller that can have the graphics and everything inside of it and use its MSTP bus to connect to the terminal units. And we don't put a supervisory device in place. And that's it. That's all we need. Now, if this is a larger campus or maybe they are focused on redundancy, we may put a different architecture in place. But the last thing we do as part of our hardware engineering is define our riser and define our controller selection. I see a lot of newer hardware engineers. They like to select their controllers first. They like to create their architecture first. And then and only then do they dive into their controllers. And then and only then do they dive into their IO. And in my experience, that's the completely opposite way of doing it, that it should be done. We start with our IO, then we size our controllers, and then we size our architecture. And by doing that, we are producing a design that meets the scope and intent at the most reasonable cost. And so we're providing a built design. And the nice thing is, as you do this, you can actually build out a library of terminal units and their points list. And so you can build this out and create basically a template library of all of these details. And that will become really important if you want to scale your hardware engineering. All right, so to recap the 5 steps: step 1, release to operations; step 2, takeoff; step 3, addressing physical points; step 4, sizing the controllers; and step 5, handling the architecture. Now, if you found this really interesting, I encourage you to go to our site and register for our controls engineering bootcamp, which will be opening up on Friday the 18th. I encourage you to look into that. And now I will take any questions you have for the remainder of the time here. So if you have any questions, feel free to type them in the chat. Do realize that there is a slight delay in the questions reaching me because this is a live stream. So if it takes me a couple seconds where we're staring at each other in the quietness, that is because of the fact that this is a live stream and there's just that delay. But I will answer your questions on anything related to this. And in next week's episode, we're going to start unpacking this even further. But yeah, it's pretty easy. It's a set of processes that once you learn these processes, you can repeat this, whether it's a $1 million controls project or, a $5, a $5,000. Yeah, that would be a really small controls project, $5. Yay, I got a sensor. I got a resistor. That's about all you would get. You'd get a couple resistors. You can't even buy most sensors for $5. So, but yeah, feel free to ask any questions you got, and I will answer those questions as I get them. And if you don't have any questions, then we'll just call it a night. So I'll give you a couple seconds. Alrighty. Okay, well, not seeing any questions, so you're going to make my life super easy because that means that I don't have to go and answer anything. So with that being said, thanks a ton for watching. Be sure to tune in Wednesday morning at 8 a.m. Central Daylight Time. And as always, please leave any questions you have in the comments. If you're watching this after the live stream, I'd love to answer them for you. I love ideas on future courses. And you also will find in the description of this live video, once it's posted, you will find a link to the Controls Engineering Bootcamp. That being said, hey, thanks so much for being here. I look forward to seeing y'all in the future live stream. Thanks a ton and have a great night. Take care.